Hello, very good morning students. Last day I have discussed the proof of Pythagoras theorem, and today I want to discuss the application of Pythagoras theorem. So many sums, maybe short questions or theoretical questions from your book I want to discuss. First, a short type of question. What type of questions? Try to clear. Say, the three sides of a triangle are given. Three sides of a triangle are given. You have to test whether the triangle is right angle triangle or not. In Pythagoras theorem, what you have got last day? For a right angle triangle, always Pythagoras theorem is applicable, and the result is square of the hypotenuse always equal to sum of the squares of other two sides. For example, as a short question, say question number 1, it is given that the three sides of a triangle are like 3 centimeter, 4 centimeter and 5 centimeter. We are going to test whether the triangle is right angle or not. If it is right angle triangle, then also you have to say which side is hypotenuse. How to test? First you can give the name. Let the first side is A, second side is B and third side is C. After that, what is the calculation you will do? You will find the sum of the squares of all the three sides, like square equal to 9, B square equal to 16 and C square equal to 25. Now, Pythagoras theorem was what? Sum of the squares of any two sides equal to the hypotenuse square means the square of the third side. It is clearly from the result what we are getting. The two smaller result, if we add square plus b square equal to 9 plus 16 and 9 plus 16, very simple calculation is 25. And you see the 25 is the value of also c square. So what we have proved? Sum of the square of two sides of the triangle is equal to third side square. Means the triangle is holding the Pythagoras theorem and it is right angle triangle obviously. So its hypotenuse is the longest side, that is longest side is 5 centimeter. So what is our answer? Yes, the three sides 3 centimeter, 4 centimeter, 5 centimeter are obviously the sides of a right angle triangle. The another testing, for another example, say the three sides of a triangle, this type of so many questions given in your book, are 6 centimeter, 6 root 3 centimeter and say 12 centimeter. Again, at the same way, if we test A equal to this, B equal to this and C equal to this, take the squares. Square equal to 36, B square equal to 36 into 3, that is 108 and C square equal to 12 square 144, very common result. Again, if we add the two smaller values like square plus b square equal to 36 plus 108, by addition it is coming 144 also, and not only that, we have 144 also equal to third square. So again the same conclusion, yes, these three sides are also the sides of a right angle triangle, as the sides are holding the Pythagoras theorem. And not only that, see, 12 centimeter is the longest side, obviously is its hypotenuse. So this type of short questions, so many given in your book, I think you will be able to do. And not only that, say square plus, in my both the example, this is coming square plus b square equal to c square. Say the third square is 13 square, 13. Then 13 square is 169, that you know. And in this case, square plus b square equal to 144, which is not equal to 169. So it is not holding the Pythagoras theorem. We can draw the conclusion, no, these three sides, 6 centimeter, 6 root 3 centimeter and 13 centimeter are not the side of a right angle triangle. I think it is clear. Now, one of the most important question from your book, look at the board. What is the question? Say, this is an equilateral triangle ABC. The question given in your book, equilateral triangle means all three sides as well as all three angles equal, each angle equal to 60 degrees, that you know from the lower classes. Say it is given in the question paper, each side length is 2a, 2a, 2a. Question is what? We have to calculate the length of altitude. You know, altitude means from any vertex, the perpendicular on the opposite side. I am drawing one of the altitude, like AD is the altitude 90 degree, and as it is equilateral triangle, you say this side equal, this one 90 degree. Obviously D should be the midpoint. Not only that, by congruency of triangle you can prove both the triangles are congruent, so BD must be equal to DC. And not only that, BC value is 2D, 2A, therefore BD equal to DC equal to 2A by 2 must be equal to A. Each part, this is A, that's why the total is 2A. We have to calculate the altitude AD, DC is A, AC is 2A. Apply the Pythagoras in this triangle ADC. So we are writing in triangle ADC. If I use the Pythagoras, what you are getting? AD square plus DC square is equal to AC square. That is AD square plus DC value already we have got square plus equals to AC value, that is 2A whole square, or AD square equal to 2A whole square is 4 square minus square, that is equal to 3 square, and therefore AD equal to root 3 and A. So an equilateral triangle whose each side is 2A centimeter or 2A unit, the altitude will be root 3 into A. The question given in your book as a 2-mark question, it is most important. So I think you will be able to do this type of also so many sums. Say instead of 2A, the another value is given. Question is calculate the altitude. In the same manner, you will just able to calculate, and I think you can understand. Not only that, most of the theoretical question from your book, try to clear. Last day, the question is same as Pythagoras theorem proof. So what is the question? It is also given in your book. At the time of Pythagoras theorem proof, also this type of sums you have done in your book. The sum is given as a application of Pythagoras theorem. Say ABC is a right angle triangle. Right angle is at A. You see the diagram same as the Pythagoras theorem proof. That same diagram. AD is the altitude. This is 90. What we have to prove? You have to prove AD square equal to BD into DC. Question is given. What theoretical question? In right angle triangle ABC, angle A is 90 degrees, AD is the altitude or AD perpendicular to BC, prove that this. Now, at the time of Pythagoras theorem, we have proved and we have marked if this angle is x, this is 90, this angle is 90 minus x, last day you have done, this angle is 90 minus x is only x. In the largest triangle, this is x, this one is 90, the third angle is also 90 minus x. Now you see, out of the three right angle triangles, ADB, ADC and original triangle ABC, all are right angle triangles and all the triangles are equiangular. Last day also I said. So here, first triangle, second triangle are similar. This small triangle, full triangle are also similar. Right side small triangle ADC and full triangle ABC are also similar. So for this particular proof, what we are taking, both the small triangles we are taking, you are writing the twin triangle ABD and triangle ADC. Like the last day you have proved what? We want to prove these two triangles similar. So angle B equal to angle B equal to, you see, angle DAC. You see, this is x, this angle is also x. Already by calculation, not only that, in this triangle, angle ADB 90 degrees. Again in this triangle, angle ADC also equal to 90 degrees. So both the angles, two angles equal. Therefore, the conclusion, triangle ABD similar to triangle ADC. The property you know, angle property. Now, when two triangles are similar, from first day you are doing, what is the result? Ratio of their corresponding sides must be equal or the corresponding sides are proportional. Take the sides. Therefore, we are taking the sides, you see, in front of angle B, the x, and here is angle x. So opposite of this angle in the first triangle, we are getting the side AD. Similarly, opposite of this x in the second triangle, the side is DC. Not only that, opposite of, you see, 90 minus x in the first triangle, the side is BD, and opposite of 90 minus x same angle in the second triangle, the side is AD. Third one not required for the particular result. By cross multiplication, AD into AD, we are getting AD square equal to BD into DC. This is our required proof. Very simple. This one actually a part of the proof of Pythagoras theorem. So this one, as a sum given in your book, I think you will be able to understand and to practice. And this type of application, so many given in your book, you have to do all. In exam, this type of sums are all important. Now, one of the good application given the type of sum in your book, what is the sum? Try to clear. Our next sum is, say there are two vertical poles. This one 90 degrees with the base. 90 degree means it is vertical. I am giving the name like AB. There is another pole, and not only that, for the first pole the length is 6 meter given in your book. The second vertical pole I am taking the name like CD. Not only that, the distance between the foot of the vertical pole is given 12 centimeter. Question is, the length of second pole is like 11 meter. So I repeat the question. The question is given in your book. This is the first pole. This is the second pole. The length of first one 6 meter. Length of second one is 11 meter. Distance between their foot, what? 12 meter. What is the question? Find the distance between their tops. Find the distance between their tops. So first you join the tops. You see, in the diagram, to get the right angle triangle, a construction of perpendicular from A is drawn on the line CD. So as it is perpendicular, this is also 90. The co-anterior angle are equal. So this line must be parallel to this. This is also right angle triangle. And this one, you see 90, 90, 90. This side parallel. This side parallel. You know what is the diagram? This one. This is nothing but a rectangle. So as this is 12, the opposite side I am giving the name like AM is also 12 meter. As this one is 6, MD is also 6, but the total length 11. So remaining part CM equal to 11 minus 6, that is 5 meter. So this one is 5 meter. Now if we apply the Pythagoras in triangle AMC, use the Pythagoras. AC square equal to hypotenuse square equal to sum of the squares of other two sides, that is AM square plus MC square. Substitute the values. 12 square plus 5 square, that is 12 square is 144 plus 25 is 169, and therefore AC equal to root over 169, that is 13 centimeter. So what is the final answer? The distance between their tops is 13 centimeter. I think it is clear. Now this type of more sums also given in your book. 1-2 type of sums, and that will be most important. Sometimes coming in the board exam also. What? Look at the board. Again the sum is from a right angle triangle, from a equilateral triangle. Try to clear. Say A, B, C is an equilateral triangle. Again the altitude is drawn. I said in the previous sum also, in equilateral triangle when three sides equal, if I draw the altitude, these two parts must be equal. For this question, I repeat the question. In triangle ABC, AD is the altitude. Prove that 4 into altitude square equal to 3 into any one side whole square. Very, very important question. How to prove? In one sum already we have calculated the altitude just like that. You see, out of the two equal right angle triangles, you can use the Pythagoras in any one. Say I am taking the right angle triangle ADC. In right triangle ADC, if I consider the side of the triangle, each side is like A, this one is also A, this is A by 2, this is also A by 2, or you can say what? BC is half of BC. Without taking A also you can do the sum. So first, AD square equal to Pythagoras theorem, AD square plus DC square is equal to AC square. Same calculation we did in the previous sum also, and therefore AD square equal to, see, AC value is square minus DC value is A by 2 whole square, that is square minus square by 4, that is 4 is the LCM, that is 4 square minus square is 3 square by 4, and therefore AD square equal to Cross multiply 4 into AD square equal to 3 into a square, which implies what? 4 into AD square equal to 3 into a square. Instead of A, you can write either AB or BC or SC. In the question paper when it is AB, so small a means also we can write AB square. So this is the proof. Very simple. Now, one of the most theoretical question